Hi, this is Peter Smallage. I'm the director of the Cornell University Arnot Teaching and Research Forest, and I'm pleased to host the 2012 presentations of the Undergraduate Research Intern Program. This presentation will be by Devin McMahon. She's an undergraduate biology student in the College of Agriculture and Life Sciences, and she will be talking about the effects of woody debris piles on salamanders. So let me open Devin's presentation. There's Devin's presentation. I'll turn the baton over to Devin.
All right.
Thank you, Devin. The floor is yours.
Thanks, Pete. So I'm Devin McMahon. I worked at the Arnot this summer, and I'd like to talk about the effects of woody debris piles on salamanders. And before I start, I'd just like to thank my mentors and co-authors, Christy Sullivan and Steve Moriali. I'd also like to thank Gary Goff, Pete Smallage, and Kathy Coates for all their help with the Arnot this summer. And I'd like to thank my fellow interns, Cassie Garcia and Seth Letter. So what is debris, and why are we putting it in piles? Debris is really a bit of a misnomer because it implies that this is not useful material, it's just kind of trash. But woody debris can actually be very beneficial. Debris is the term for the pieces of trees that are left behind in a logging or forest management operation. So tree tops, branches, and bits that fall off. And this debris can be, it can have a couple of fates. You can leave it on the forest floor, where it can provide a favorable microenvironment for a lot of organisms. Or you can remove the debris with some of this machinery shown here and use it potentially as a source of biofuels. So these can both be beneficial options, but they're obviously in conflict. So our group is studying the benefits of leaving woody debris in piles and also potential negative consequences of removing all of that woody debris. My objective in this study was to determine the effects of piled woody debris on salamander abundance and salamander body condition, because salamanders are an important proxy for lots of organisms that live on the forest floor. And this picture here is an example of what I'm talking about when I say a pile of woody debris. So the salamanders we looked at included quite a few species. The red-backed salamanders on the left are the most common species and the ones we did our body composition measurements on. But we also found newts, slimy salamanders, spotted salamanders, and several other species that are located in central southern New York where we did our experiments. And how we looked for these salamanders was in these experimental plots we set up. So within a stand of trees that has been thinned, so going through and removing select trees, not a clear-cut logging operation, we set up these 3 different 1.5 hectare patches. And in each patch, we removed a different amount of woody material. So in the 10-inch plot, all the woody material greater than 10 inches in diameter was removed, and everything less than 10 inches in diameter was retained on the forest floor and piled throughout the plot, so that some areas have a pile of wood and some areas don't really have a lot of wood. In the 4-inch treatment, similarly, a little more removal. So everything larger than 4 inches in diameter was hauled out of the plot, and everything less than 4 inches in diameter was piled. And then finally, the whole tree removal is the most woody material removed. Everything is taken out, and very little is left behind, no piles. And then this treatment with, or this setup with the 3 different treatments near each other for ease of comparison was replicated at 3 different sites in central southern New York. So 1 at the Arnot Forest, and then 2 at Mount Pleasant near Ithaca. And so just to review, the least woody material removal, that's the 10-inch treatment. 4-inch, a bit more removal, and full tree removal is taking out pretty much all of the woody material. And here's the visualization of what that looks like. So you can see in the 10-inch plot, this is shortly after it's been cut, before it's been piled. There are some log-type things. There are a lot of branches, 4 inches, branches, but not anything you'd really call a log. And then the whole tree removal pretty much no woody debris is left. There are some bits that were hard to pick up. And so in each of these plots, we searched for salamanders in two different ways. One method was the transect method, where you walk in a line through one of the treatments, say the 10-inch treatment, and you flip over all of the rocks and sticks and bark that are on the ground without taking apart the piles, of course. And you count all the rocks and sticks and bark you find, and you count all the salamanders that you find underneath them. And we use this method to compare between the 4-inch and 10-inch and whole tree treatments to see how the treatment affects salamander abundance. And there's also the intensive quadrat survey, where you basically lay out a 2 by 2 meter square, and you tear up everything that's in there and all the plants and leaf litter, and you search all of that for salamanders and see how many you find. And we use this to see whether salamanders were more abundant near piles or farther away from them. And then when we caught salamanders of the most common species, the redback salamanders, we also weighed and measured these salamanders. So we weighed them on a gram scale, and we measured snout to vent length and total body length, which are common methods for measuring salamanders. So what did we find? We did these transect sampling first. We did 30 sets of 3 transects. So every time we did a transect sample, we would run a transect in, say, the 10-inch plot, and then we'd do one in the whole tree plot and one in the 4-inch plot within a short span of time, so we would be able to compare them later. So we did 30 of these sets between the 3 sites. We turned over 9,000 objects. We found over 400 salamanders of 5 different species, and we weighed and measured 222 redback salamanders. What we found was differential salamander abundance between the plots that maintained woody material and plots where all the woody material was removed. So in these 30 transects, we calculated the mean number of salamanders we found under an object turned over. So taking all the salamanders we found in that transect and dividing by all the objects we turned over. So we did this in each of 3 different sites, and in each site, as shown in this graph, there are fewer salamanders in the whole tree removal treatment. That's indicated by the yellow bars on the graph. And you can see that the yellow bars demonstrate that there's less salamander abundance in the treatments where all of the woody material was removed compared to the purple and blue, which are the treatments where some woody material was retained. So this is the same information pooling all 3 sites. The reason we've shown the 3 sites is because the trend is the same despite considerable variability between the 3 sites and how many salamanders there actually are. So here's the pooled data. Again, you can see that the abundance of salamanders per object in the whole tree removal treatment is less than in the treatments that maintain some woody debris. So we wanted to see if that difference was significant. So because we'd run the transects in each treatment within a short amount of time in the same site, we were able to do paired t-tests to compare the salamander abundance in different treatments. And what we found at the 0.05 alpha level was highly significant difference between the 4-inch treatment with some woody material and the whole tree removal treatment. So significantly more salamanders where there was some debris left behind. The difference between the 10-inch and whole tree treatments was on the cusp of significance, much more significant than the difference between the 2 treatments in which woody material was retained. So in general, the biggest effect was between removing all the woody material and retaining some in terms of salamander abundance. So we saw that salamander abundance increased when there was some woody material on the treatment level. We also wanted to see whether we find more salamanders close to piles of woody debris and whether those piles are serving as a population source from salamanders that then radiate throughout the treatment. So we did this with the intensive quadrat survey, and the results were kind of inconclusive. Looking at just this year's data, we did find significantly more salamanders closer to the piles, so about 2 meters away from the piles versus about 7 meters away. But when we took that data for the past 4 years and pulled that together, the significance vanished. So this is going to take some more study. One of the major caveats on this method is that we can't actually take apart the piles to find out how many salamanders are in there. So it's possible that there are lots of salamanders inside the piles themselves, but depending on the conditions that year, they may or may not be radiating out from the pile. So we'll get back to you on this. More studies required. The last thing we wanted to do was look at whether woody material abundance affects salamander body condition. So the idea here is that if you're more massive for your body length, you're a fatter, happier, healthier salamander that's better prepared for anything the environment throws at you. And we wanted to see whether woody debris improves salamander condition. So we weighed and measured all of these salamanders, and we fit a nice log linear regression that fit our data pretty nicely, R-squared of 92.7, to create this line that kind of indicates the average salamander and how much it weighs for its body length. And then we compared the weight per body length between treatments. And what we found was that there wasn't a significant difference in the residuals from this line among the 10-inch and 4-inch and whole tree treatments. So salamanders in all 3 treatments were of comparable body condition, despite being more abundant in the treatments where woody debris was left behind. So in conclusion, the woody debris piles increased the quantity while maintaining the quality of the salamanders. Like I said, woody debris piles increased salamander abundance, didn't significantly affect body condition. And this is important because salamanders are a proxy for all of these different organisms on the forest floor. So fungi and arthropods and small mammals and plants and tree seedlings. And tree seedlings are super important because they are the future of the forest. And we're finding that woody debris can help with their regeneration and provide a favorable microenvironment for them, just like it does for salamanders. So in general, we're finding that complete removal of woody material for biofuel or for any other reason can have negative impact on the forest ecosystems. Something to consider for the future management of forests. Thank you.
Devin, that was a great job. Thank you for providing this presentation, and we enjoyed having you as an intern this summer at the Arnot. Good luck with your finals.
Thanks.